AP Cram Calculus AB Free Response Exam Review. Question 31. Increasing and concave down. The function f is defined on the closed interval -5, 4, and when an interval is closed and bracketed off like this, it means that the interval also includes the endpoints -5 and 4. Okay. The graph of f consists of 3 line segments shown here, 1, 2, 3, and is shown in the figure. Let g be the function defined by g of x is equivalent to the integral from -3 to x of f of t dt. Okay, so g of x is the integral of f of t. On what open intervals contained in -5, x is between -5, 4, is the graph of g both increasing, that means going up, and concave down. In addition to explaining the intervals, give a reason for your answer. All right. In an effort to establish which intervals are increasing and concave down, we're going to have to find g prime of x. And in order to find g prime of x, we're going to have to pull one main trick out of our bag of goodies, and that's the good old fundamental theorem of calculus. Since we're integrating f of t to find g of x, g prime of x is just the derivative of the integral of f of t dt, because the fundamental theorem of calculus links integration and differentiation as being opposite functions to each other. Okay, so we have to basically take the derivative of g of x. And the reason why we're taking the derivative of g of x is to kind of sort of run a first derivative test and establish critical points. So these are the critical points of g prime of x, or simply f of x. Okay, so we just established using the fundamental theorem of calculus that g prime of x is equivalent to f of x. So now we can go to this graph and start analyzing some things. Wherever g prime of x is equivalent to 0, these are critical points. They could be maximums or minimums, but that's not what we're really looking for here. We're looking for points of inflection, okay? Because before this critical point, we see that the slope is decreasing but positive. And we see after the critical point, the slope is increasing, but positive as well. Okay, so that's going to tell us a lot. And here again, we see the slope is decreasing but positive, and then increasing, decreasing, and negative. Okay, so this is like a local minimum, a local maximum, and then this point is going to be like a local maximum as well. Well, actually, yeah. Excuse me, it's going to be a local minimum, because if it's telling us that the activity of G is decreasing but positive, and then increasing and positive, that you're coming to a dipping point, okay? And this is kind of sort of essentially what we want to know. Basically, the graph of G is increasing and concave down on the intervals on, -5, and where x is between -5 and -3. So it's going to be decreasing and concave down between -5 and -3. And it's also going to be increasing and concave down on the interval between 0 and 2. And so I just established this for you. that basically on the actual graph of G, here, the slope would be slowly decreasing but positive. All right, and here as well, the slope would be slowly decreasing but positive. All right. All right. So I misspoke. This is going to be a local maximum as well. Okay. All right.